Hi everyone! Today we will create a full-stack data science dashboard absolutely from scratch. We will download some financial stock data, we will display it in a beautiful interface, and we will predict its future values using different algorithms. Now, the best part is our app will be 100% production ready using Python only. No HTML, no CSS, and most certainly no JavaScript. For this, we will use an open source library named Taipy, which we've used in the past but in a relatively simple application. What we are making today is far more advanced and it is extra useful if you are trading stocks. So are you ready? Let's roll! So let's begin by setting up the environment. We will navigate to our WSL terminal, and if you don't have one, I've included installation instructions in the description. We will then create a new working environment with conda create-n, and we will call it DS, as in Data Science installing Python 3.11 init. We will of course activate it, and we will pip install Taipy inside it. Next, we will download all the images that we will need for our project with git clone, followed by the URL of my GitHub repository, which you can copy from the description. Now, once the download is complete, we will go ahead and navigate to our starter files directory with cd data science dashboard /starter_files. And from now on, we will call this lovely folder the root directory of our project. Now let's have a quick look through our file system. We will find an images directory with a bunch of flags of different countries, as well as icons of IDs, logos, and some machine learning algorithms. In addition, we will find a wireframe file, which we will use as a reference for our GUI right next to a Python file named main.py. So let's quickly open it with a code editor where we will find a basic Taipy application. It has no functionality and almost no content, and it is slightly different from our previous project, where instead of using the Taipy GUI builder, we've used the Markdown style syntax instead. Great! So now that we're familiar with our files, let's fill our GUI page with some elements. Now, starting from the top of our wireframe, we have a logo and a heading. So let's quickly add them to the page with tgb, as in Taipy GUI builder dot image, to which we will pass a path of images/icons/logo.png. Then we will convert our demo text into a heading by specifying the mode of MD, as in Markdown, which will now give a special meaning to Markdown symbols such as hashtags that indicate headings. In our case, S&P 500 stock value over time. Now let's quickly save this file. Let's navigate to our terminal and let's run our application with Taipy run main.py. Then we will navigate to our browser and we will type localhost in the port of 5000. Okay, here's our logo and heading, but the only problem is they are not centered on the page and our logo is huge. So let's fix it. We will add the property of width to our image, as in wide, and we will assign it to a string with 10 VW, as in viewport width. Now, in terms of alignment, we will group our elements together using the with keyword, WITH this time, followed by tgb.part, to which we will pass the CSS class of text-center. Now, since we are dealing with a with statement, we will wrap it in a colon and we will indent the elements below it, resulting in one parent element of part block and two children elements of image and text. Now let's quickly save our file. Let's go back to our terminal, collapse our application with Ctrl+C, and restart it with the up arrow and enter. And yay! It worked! Now, if we quickly open the developer tools with a right click followed by inspect, we can actually select our part block, revealing both the children elements inside it. And if we expand our image, we can see it has the style of width 10VW. So it gives you a nice idea of how your Python is translated into HTML. Next, we will take care of the date range element. So at the very top of our code, we will import the datetime module, and we will create a global variable of dates, assigning it to a list with the datetime.date of 2023 January 1st, right alongside datetime.date 2024 January 1st as well. And now that we have a start date and a finish date, we will navigate to the bottom of our part block and create a date range element with tgb.date_range, passing it our global dates in a set of quotes, curly brackets, and inside them, dates. Why? Because that's how we associate the global variable of dates with our date range GUI element. Now, if we're already here, let's also give it the label_start of start date, as well as the label_end of end date. And then lastly, since we don't want to collapse and then rerun our app time and time again, we will navigate to our ifName main section, and we will add the property of use_reloader and set it to true right inside our GUI.run method. And that way, instead of collapsing and rerunning our app, we can simply click on refresh and all the changes we have made will be automatically reloaded. Great, so now let's save our file, let's navigate to our terminal, let's collapse and rerun our app for the very last time. And beautiful, here's our super fancy date range selector. And speaking of selectors, let's move on with the country and company ones. Now, since both of them are placed on the same row, one besides the other, let's group them together in a layout element. For this, we will navigate to our code, and right below our date range, we will type with tgb.layout, to which we will pass the width of our columns in a string, giving the first column the width of 20 and the second column the remaining 80. And as you may guess, we are dealing with percentages. Now, for our 20% column, we will create a tgb.selector with the label of country, and similarly, for our 80% column, we will create a selector with the label of company. Additionally, we will give both our selectors the class_name of full width. And before we move on, let's quickly save everything. Let's refresh our browser. And okay, the placement looks great. So now let's fill those selectors with values. Now, since we don't have a dataset just yet, let's start with some placeholders. Now, in our case, we will need a placeholder named country, and we will set it to Canada. The second one is company, which we will set to the fictional Wayne Enterprises. Then we will associate these two variables with their respective GUI selectors. For this, we will give our country selector the value of a set of quotes with some curly brackets, and inside them, our country global variable. Similarly, we will copy this line of code and we will apply it on our companies, replacing the country global with the company global. But that's not all. Our selectors also need a list of values to choose from, which is represented by the LOV property. Now, in the case of our countries selector, we will give it the list of values of USA and the already selected Canada. Now, when it comes to our companies, we will give it an LOV of a list with Wayne Enterprises, as well as, let's say, Umbrella Corp. Now let's fix this list indentation. Let's save everything. Let's navigate to our browser, refresh it, and great. We are selecting the correct items. But now let's also hide the items that we are not selecting. For this, we will simply add the property of dropdown and set it to true for both our selectors. Now, once we do so, we can refresh our browser, and boom, our selectors look much better. So now we're down to the chart element, which we will add right below our layout with tgb.chart. And for now, we will leave it blank because we don't have any data just yet. And then lastly, we have our predictions for the next business day given by 3 different algorithms. And since all these little elements are on the same row, just like our selectors, we will group them together in a layout element once again. So back in our code, right below our chart, we will go ahead and type with tgb.layout, and at first we will give each of our 8 columns the width of 5%. And then we will create each of our elements from left to right. So starting with a tgb.image with the path of images/icons/id-card.png. And we will also give it the width of 3 VW so that hopefully it fits nicely in our 5% of the viewport. Now, right next to the icon, we have a tgb.text that stores the global variable of company. Now, let's copy these lines of code and let's create the rest of our 6 elements using the same pattern, okay? So our first prediction algorithm is called linear regression, and that's why its icon corresponds to lin.png. Now, our second algorithm is called k-nearest neighbors under knn.png. And then lastly, we have a recurrent neural network, or rnn.png. Now, in terms of text, we will create 3 global variables that at first will store a bunch of placeholders. So right below our country and company, we will create a lin pred and set it to 0. And we will repeat the same for our k and n pred and our r and n pred. Now, once these variables exist, we can then go ahead and specify them inside our GUI text, giving our lin icon the text of lin pred, then giving our k and n icon the text of k and n pred, and then lastly, r and n pred. Now let's save everything, let's give it a nice look, and there you go, here's our chart, and there's all our nice prediction elements underneath it. But now, let's style it according to the same principles as our wireframe, or in other words, let's give our company text the vast majority of the viewport. So if 7 of our elements have the width of 5 and take 35% of the viewport, then it leaves us 65% for the company name. So let's quickly save everything, let's refresh our browser, and okay, it's better, but it's gonna look much better if our text is aligned to the left. So back in our code, we will copy our part block from above, and we will wrap our new layout in it. But instead of giving it the CSS class of text center, we will give it the CSS class of text left. And we will, of course, indent the rest of the code. Otherwise, it's not gonna work. Let's save it. Let's have another look. Okay, much better, but it's still not perfect. Our algorithms should be placed a bit more to the right in terms of horizontal alignment, and in terms of vertical alignment, our text is a bit too high. So let's take care of these. Now, we can fix the horizontal stuff by giving most of our elements the width of 4, which leaves 72% for our company name. And in terms of vertical alignment, there's actually a very simple trick of giving our text the mode of MD. And once we set each of our text elements to the mode of Markdown, the alignment will be fixed automatically. So let's refresh our page, and boom, our interface looks exactly like our wireframe. So good job, folks. We can finally move on with our dataset. And as you may guess, we will go for the S&P 500 stocks dataset, which you can find on Kaggle. Just please make sure it is updated daily and it has a usability score of 10 out of 10. Now let's go ahead and download it, extracting it in a new directory named data at the root of our project. And inside it, we will find 3 CSV files. So let's go ahead and load one of them, specifically the S&P 500 stocks. Let's copy the name. And then back in our code, we will go ahead and import pandas as PD. And right below, we will load our file with pd.read_csv, passing it a string of data / the name of our file. Let's go ahead and assign it to stock_data, printing it right below. And actually, let's focus on the location of row number 0. Let's save it. Let's go back to our browser. Let's refresh our app. And then inside our terminal, we will find the output of our print statement. Great. So this will work for all kinds of hardware. But I also have a quick bonus to those with special kind of hardware. So if you have an NVIDIA-based GPU, you can actually accelerate the speed of your tasks using cuDF Pandas rather than the traditional CPU-based Pandas. And we will use the exact same commands, just a little bit faster. Now, to set it up, we will need to deactivate our environment with conda deactivate, and we will create a new one using the official command from the Rapids documentation. We will go ahead and copy it. You can also find it in the description, and we will paste it back in our terminal, renaming this environment from Rapids 2410 to ds_GPU. And once our new environment is set up and activated, we can then go ahead and pip install Taipy. And yes, the order is very important. And now our only adjustments in terms of code would be importing cuDF.pandas, as well as calling cuDF.pandas.install right before we import pandas as PD. And as long as we add these two lines of code, we are dealing with the accelerated pandas that runs on GPU. Everything else will remain the same. So let's go ahead and save our file. Let's go ahead and rerun it. And beautiful, we get the exact same output, just a little bit faster. Now, inside our print statement, we see that stocks have a date, a symbol, a volume, and a value that changes throughout the day. Now, in my case, I will focus on the adjusted closing price, but please feel free to focus on anything else you'd like. Now, the only problem with this dataset is that it doesn't tell us the actual name of the company. We can only see the trading symbol, and we have no idea which country this company is from. So let's also have a look at the company's dataset that you can find over here. So back in our code, we will simply copy our stock data commands, and we will adjust stocks to companies and stock data to company data. Now let's go ahead and save our file. Let's refresh it. Let's have a look in the terminal. We will scroll down, and now we see the company data as well. So in addition to storing our symbol, we can also see a short name as well as the country where the company is registered. And that way we can fill all our placeholders with actual values. For this, we will create a new variable named country names, and we will assign it to company data in the column of country. And since we only want one instance of each country, we will also call the unique method on it. Now, in addition to countries, we also need company names and their symbols. So let's go ahead and call company data, focusing on the columns of symbol and short name. And since this time we are dealing with 500 different values, it also makes sense to sort them alphabetically. That way we'll be able to search through them much easier. So let's wrap it in a sort_values method, and we will sort by the short name column. Now, before I break this down into a multi-liner so you can see it better, let's go ahead and give this expression a name, in my case, company names. Okay, and now I'm going to break it into a multi-liner. Ha, much better. Now let's go ahead and also print these two variables. And let's get rid of our print statements from above. We already know how our data looks like. Great, let's save it. Let's refresh our page. And then back in our terminal, we will find our list of countries as well as our company names sorted alphabetically, with the exclusion of eBay and Lululemon that start with a lowercase character. Now, before we insert our countries and companies into a selector, we will need to convert them into a list. And that's why we will convert our company names data frame first into a NumPy array with .values, And then we will convert it into a list by calling the toList method on it. Similarly, we will convert our country names NumPy array into a list by calling .toList again. And only now we can specify these two variables inside our LOV property. So let's scroll down and we will replace our list of USA and Canada with some quotes, curly brackets, and inside them, country_names. Similarly, we will replace our company's LOV with some company names. Now let's save our file. Let's navigate to our browser. And if we click on our country selector, we can see a whole bunch of them and not just the United States. Now, when it comes to companies, we are still selecting Wayne Enterprises. Okay, so we'll need to fix that. But we can also see that the LOV was updated and everything is in a nice alphabetical order. So the last thing we need to fix is our company global variable, replacing Wayne Enterprises with, let's say, Lulu. And yay, we are now selecting Lululemon. And if we choose to select a different company, then the name updates at the bottom as well. But where exactly does our selection go? To fetch it, we will use a built-in function named on_change. Now, Taipy automatically executes this function every time a GUI variable is modified. For example, when we select a new country. Now, this function takes in a state, a variable name, and a variable value, such that if the name is equal to country, then we will print name, to which we will concatenate was modified, and we will also concatenate the value at the very end. Now, similarly, if the name is actually company instead, then we will leave our print statement as is. So let's quickly see what we just did here. And if we select the company of eBay, then we see that our value is a list with a symbol as well as a company name. But if we select the country of Ireland, then the value is actually a string of Ireland. So the meaning of our values changes with the variable name. Cool? Now let's do something even cooler. Let's go ahead and place an icon of the country flag right beside its name. For this, we have a bunch of flag images that perfectly match our list of country names. So back in our code, we can use a list comprehension right below our country names, and we'll start from the basic syntax of name for name in country names, which returns an exact copy of our country names list from above. But we don't really want an exact copy, so let's go ahead and modify it. So instead of returning a name, we will return a tuple with the name right besides an icon object with a capital I. And this object takes in two arguments. The first one is the path, and the second one is the label. Now, in our case, the path of all images starts with images/flags, and then / once again, followed by the name of the country, which in our case is represented by the iteration variable of name. Okay? And then we can concatenate the .png extension. And that way, every time we are pulling a different country name and a different country icon. Now, in terms of label, that's an easy one. We simply specify the name once again. And if we now reassign our expression to country names, overriding the original list, then we can save this file, refresh our page, and now every country name comes with a lovely icon. But the only problem is if we now select a different country and we have a quick look inside our terminal, we see that our onChange function suddenly returns the name and the icon right beside it. But what if we don't care about the icon? What if we only want to retrieve the name? Or in the case of our companies, what if we'd like to retrieve the symbol, discarding the short name altogether? Well, in that case, we will go back to our selector and we will give it the property of value_by_id, setting it to true, where ID represents the first item in each of these pairs, which just happens to be a perfect match to the values we want to keep. So back in our code, we will apply the same principle on our second selector. We will save everything, refresh the page, select Singapore and eBay, which will now retrieve a single value for country and a single value for company. Amazing! We can finally move on with the backend functionality, or what on earth are we going to do with these values? So let's start with sorting our companies by their country of origin. So for example, if we select Canada, then only Canadian companies will be displayed. For this, we will use something called Taipy scenarios. And unlike our previous projects, where displaying new data required clicking on buttons and submitting a form, scenarios allow us to do so dynamically. We simply select a different country, and then new company names immediately pop. So how exactly does it work? Well, in our case, we will start with two data nodes. We receive a country as input, and we return a list of matching company names as output. So let's create a config object with a capital C, as in configure, and we will call the .configure_data_node method on it, giving it the ID of country, where the ID of country must be a perfect match to our global variable of country. We can't just choose a random name, it has to match one of our GUI variables. So let's go ahead and assign our config object to a variable of country_CFG, and we will do the exact same thing for our company names output. Now, once the data nodes are ready, we will assign them to a specific task. So using the config object, once again, we will call configure_task, and we will give it the following properties. We will give it the input of country CFG, and we will give it the output of company names CFG. And now both our data nodes are associated with this task. Additionally, we will need to associate it with a function. And in our case, it doesn't exist yet, but let's say we will call it build company names. And let's also give it a matching ID, but only encapsulated in a string. Then lastly, we will give it the skippable property, skippable, and we will set it to true, which will only perform the task when it's necessary. Now let's give our task a variable name. Let's call it build company names CFG. Now the last configuration is the scenario itself, which we will set up with config.configure_scenario and giving it the task_configs of build company names CFG. Additionally, we will give it the ID of scenario, which, just like our function from earlier, doesn't exist yet, but we will create it shortly. Now, lastly, we will assign this expression to scenario_CFG, and now we are officially done with our configurations. We took care of the input, the output, the task, as well as the scenario itself. So now let's associate these configurations with our app. For this, we will scroll to the very bottom, and right below our ifName=main block, we will initialize the Taipy orchestrator that allows us to manage scenarios. We will do so with tp.orchestrator with a capital O and an empty set of round brackets. Additionally, we will call the run method on it. Now, once our orchestrator is initialized, we can go ahead and tp.create_scenario, passing it our scenario configurations from earlier. And we will, of course, assign this expression to scenario, which must be a perfect match to the ID we gave our scenario configurations. And since our scenario stores information about our task that stores information about our input and output, it ensures that all these configurations are associated with our app. Great. Now our last task is to create this build company names function, and we will do so right above our configurations. Now, the best part is we've already decided that this function takes in a country as input and it returns a list of company names as output. Why? Because that's exactly what we've passed to our task. Okay, so how exactly do we get our list of company names? Well, how about we copy our company names global and we slightly revise it, okay? So let's paste it in our function. But this time, we don't really need all the company names. We just need the company names that are associated with a specific country. So let's add a set of square brackets to filter our values, and let's slightly fix the way that this command is written, just so we can see it a bit more vividly. Okay, so instead of all the companies, we only want to select the companies where the company data in the column of country is a perfect match to our input of country. And only in these cases, we will retrieve the symbol and short name of the companies at hand. And great, we are done with the function, but there's one more detail to take care of. Now, our very last task here is to update the scenario as soon as a new country is selected, which happens inside the onChange function and specifically inside the ifName equals country condition. Now, this update happens in several stages. In the first stage, we update the inputs. In the second one, we submit them, and in the last stage, we fetch the outputs and store them back to our global variable. So let's go ahead and unpack it step by step. So in the first stage, we will type state.scenario.country, which of course represents our input data node. So to update it, we will simply call the write method on it, and we will pass it the changing country value. Then we will submit our scenario with state.scenario.submit, which will then execute our build company names function. Now, to give it enough time, we will pass it the property of wait, and we will set it to true. And now once our new outputs were generated, we can go ahead and fetch them with state.scenario.company names, which of course represents our output data node, but instead of calling write, we will call read on it. And now once the outputs were fetched, we will store them back in our company names global variable with no typos. But there's just one problem. We can't really access our global variables from the scope of the onChange function. We can only do so through our state. So instead of assigning our expression to company names, we will assign it to state.company names. You will see shortly why, but for now, let's save everything, let's go back to our browser, and let's make sure I didn't have any typos. So now, if we select a different country, let's say Bermuda, then we only get 2 companies in return. But if we select a country like the United States, then we get a whole bunch of them back. And yay, our scenarios officially work. So good job, everyone. Now, before we move on, let's quickly see what's going on in the background. So let's compare country with state.country. And we will do so before and after the scenario updates. Let's save everything, let's navigate to our browser, and let's select a different country, which will trigger the onChange function. And then inside our terminal, we see that state.country updates like a charm, but our country variable is still stuck on Canada. And it doesn't matter how many different countries we will select, our country variable will still store the initial value. And that's why we access our global variables through the state. Now, another thing we notice is that our state.country is no different than the value received by onChange. So how about that? What if instead of writing our value, we will write the state.country instead? And this explains the official Taipy scenario syntax, because this one is no different than this one, so we might as well communicate on the state level. So let's go ahead and get rid of all these print statements that we don't need anymore, and we can finally move on with our graph. And once again, we will use scenarios. Now, in terms of data nodes, as long as we have a start date, a finish date, and a company symbol as inputs, we can then generate some stock data as output. So let's go ahead and copy one of our existing data nodes, and let's use it to create a new one with the ID of dates and the variable name of dates CFG. And just to remind you, dates is a global variable that stores both the start date and the finish date, which leaves us with the next input that will have the ID of company and the variable name of company CFG. Now, in terms of output, it doesn't exist yet, but I already know that I want to call it graph_data. And we will also give it a variable name that is very similar with graph data CFG. And since our dates and company exist globally, it's a good idea to create our graph data as well, just to make sure we don't forget it and nothing breaks, okay? So initially, we will assign it to none. Now, once we took care of our data nodes, we can go ahead and move on with our task. Now, to save some typing, we will once again copy an existing task and we'll slightly adjust it. So first, we are no longer dealing with a single input, but with two of them. So we will pass a list with date CFG as well as company CFG. In terms of output, we are dealing with graph_data CFG. And to make sure everything matches, let's call our function that doesn't exist yet buildGraphData and give it a matching ID. Then lastly, we will change the variable name of our configurations to buildGraphData CFG. Now, once we are done with our task configs, we can go ahead and add it inside our scenario configuration. So instead of setting our task configs to a single value, we will set it to a list with both our build company names configuration and the new build graph data ones. And now, once everything is configured, we can of course go ahead and define our function right below build company names. And we already know that this function takes in some dates as well as a company symbol. Now, initially, I just want to print the type of inputs we receive, one besides the other. And at first, we will go ahead and return an empty list instead of the actual graph data. But that's not all. We also need to update the scenario every time we select a new company, which is something we will do through our onChange function. So similar to our country condition, every time we select a new company, we will then pass its symbol along with the start date and finish date to generate our data. So let's just copy all the commands from our country condition and let's slightly adjust them in our company one. Now, first, since we are dealing with two inputs, we also need two write commands. While if we were dealing with two outputs, we would need two read commands. And same goes for 3 of them or 5 of them or 10s of them. Now, the name of our first input is state scenario dates, and we will write our state dates into it. Now, our second input would be state scenario company, to which we will write our state.company. And then lastly, we are dealing with the output of state.graphData, which we will also update right before calling read. And beautiful. Now, if we save everything, then in our terminal, we will find our start date, our finish date, as well as the company symbol. So let's go ahead and take these inputs and turn them into something we can plot. So let's select all the entries in stock data where the stock data column of symbol is equal to the function input of company. But that's not the only condition. So let's wrap it in a set of round brackets, and using the and symbol, we will specify another condition where we only want the entries where the stock data column of date is greater than the function input of dates in the index of 0, which stores our start date. And similarly, we only want the entries where the stock data column of date is lower than dates in the index of 1, which stores the end date. And actually, let's convert these into strings, because that's probably how they're stored inside the data frame. Now, once we've specified our 3 conditions, we'll go ahead and assign this expression to graph data. Let's also print it below, and let's return it instead of this empty list. Let's save our file and make sure it worked. And awesome, we are properly filtering our dates, there you go, as well as the company symbol, which is a perfect match to what I've just selected. Now the only problem is we don't really need all these columns. We only need the date and the adjusted closing price. So then back in our code, using a double set of square brackets right after our stock data, we will focus only on the date and the adjusted closing columns. So if we save it and we have another look, we only focus on the columns we need. Now, our last task here is to change the name of the adjusted closing column to match the company symbol. And that way, we can stack a whole bunch of companies, one besides the other, so we can plot them together on the same graph. So for example, in this column, we will store the ACGL values, and then right next to it, we will store the Google values, and so on and so on. So then back in our code, we will call graphData.rename, setting its columns attribute to a dictionary where the key represents the column we would like to rename, in our case ADG close, and the value represents the new name, which in our case is the function input of company. Now let's go ahead and reassign this expression back to graphData. Let's save it and let's have another look. And boom, our graph data is truly perfect. So let's go ahead and plot it. For this, we will pip install a library named Plotly. And then at the very top of our code, we will import plotly.graphObjects as Go. And then right below our build graph data function, we will create a new one. We will call it display_graph, and this function will take in our newly generated graph data. Now, our task here is to create a figure using the class of go.figure with a capital F, so that right below we can call figure.add_trace, passing it a go.scatterplot with a capital S. Now, our scatter will receive the following properties. We will give it the x-axis of graph data in the column of date. And we will give it the y-axis of our very last graph data column, which is given by graph data, where graph data.columns is in the index of -1. And we do so because this column will always have a different name, depending on the company we are selecting. So instead of hard-coding ACGL, we'll just select this column by its index. Now, in addition, we also want to give our scatter a name. In my case, we will assign it to the name of our last column with graphData.columns in the index of -1. And then lastly, we will set the show legend property to true. And we will give both our axes a title with figure.update_layout, setting the x-axis _title to date and the y-axis _title to stock value. And then at the very end of this function, we will return the figure. Okay, but where exactly do we call this function? Well, how about every time we make changes to our graph data? Now, luckily, we already know where it happens. So inside our onChange function, we will go ahead and add another condition of if name equals to graph data. And in that case, we will call our display graph function, passing it our state.graphData. Now, since this function returns a figure, we will need to assign it to something. So how about a global variable that doesn't exist yet, that is called state.figure? Okay, and then we can display this variable inside our chart. Now, before we forget, let's create it on a global level. Right below graph data, we will set figure to the initial value of none as well. And now, once we have a figure, we can go ahead and display it in our GUI. So inside our tgb.chart, we will specify the attribute of figure, assigning it to a set of quotes, curly brackets, and inside them, our global of figure with no typos. Ha! Now let's save it. Let's go back to our terminal. Let's rerun our app. And now if we select a country and a company, here's our beautiful, beautiful plot. Now, if we select a different company, our plot immediately updates. And if we select a different country and a different company, it works as well. Yay! But what if we want to plot multiple stocks on the same chart? So far, we're plotting them one after the other, but what if we'd like to compare between them? So first, let's convert our company global from a string into a list. Then we will make sure our company selector is capable of receiving multiple inputs. For this, we will set the multiple property to true. And then we are down to the fun stuff, which is basically adjusting our graph functions to work with multiple companies. For this, let's get rid of these print statements just so we can see the entire function on the screen. So if we receive multiple companies instead of just one, we can't really use our symbol filter. So let's get rid of it. And instead, let's receive our symbols as an additional column, right besides the date and the adjusted closing price. Then we can extract all the values that we need from this data frame into a new one. Okay, so let's quickly rename it to temp data, as in template data, and let's create our graph data right below it, assigning it to pd.dataframe. And let's start with our date column. So let's set our graph data in the column of date to temp data in the column of date as well. But since our dates will repeat for each and every company, we will also call the unique method on it. Then we will iterate over our companies with for I in company, giving each of them their own column. So let's type graph data in the column of I that represents each of our company symbols one at a time. So what exactly are we going to store in these columns? Well, how about temp data, where the temp data column of symbol is equal to the iteration variable of I. But we can't really store a data frame as a data frame column. So let's also convert it with dot values into a NumPy array, and then we can assign it with no issues. Now lastly, since we already take care of the dates, we don't really need the date column from our temp data. And since we also take care of the company symbols, we don't really need the symbol column as well, which leaves us with the adjusted closing column only. So instead of returning the entire data frame, let's only return the adjusted closing column. And then lastly, since each of our symbol columns already have the appropriate name, we don't need to call our renaming command underneath. And beautiful. If I don't have any typos, our build graph data function is complete, which leaves us with the display graph function only. And here it's a bit trickier because each and every company must have its own instance of addTrace. So let's create a local variable of symbols and let's assign it to graphData.columns. But instead of the column at index -1, we will select all the columns starting from column 1 up until the very end, which is basically all the columns other than the one at index 0 that stores our dates. Okay, and if that's the case, we can then call for I in symbols. We can then indent our addTrace instance, and then we will replace each graphData.columns instance with I, doing so in the Y attribute as well as in the name attribute. And okay, if everything worked, hopefully no typos, let's save it. Let's go back to our browser. And okay, we already see that our selector is a bit different. So what happens if we choose the United States? And what happens if we choose 3M? Beautiful! We are now plotting both of these stocks on the same chart. So what if we select another company, and another one, and another one, and another one, and another one, and wow, holy smokes, you guys, it works like a charm. Now, if that's too much information, we can actually get rid of some of these stocks by clicking on the X icon. Now, you wonder what happens to our first company that is selected under a different country And beautiful, our selector still remembers this company, so we can get rid of it in the same fashion as our United States companies. Amazing! Good job, everyone! We are officially plotting multiple companies on the same graph. But before we move on with all the machine learning stuff, there are actually a few minor fixes to take care of. So if we look at the bottom, we see that our companies just keep accumulating and accumulating, while in reality, we only want to display the most recent company selected by the user. Additionally, our date range element is not connected to anything, so if we select a different date, our interface doesn't change at all. So let's fix that. Now, a simple trick to fix our dates is inside the onChange function. Specifically, inside the ifName equals company condition that submits our dates to the scenario. So instead of the existing condition, let's change it to ifName equals company or name equals dates. And then at the very top of our code, instead of focusing on year 2023, we will set the start date of stock data in the column of date.min, which will of course select the earliest date in the data frame. And similarly, we will repeat it for our end date, setting it to stock data in the column of date.max. Now, in terms of the company symbols, we will navigate to our GUI, and then right beside our ID card icon, we will set the text of company in the index of -1, displaying a string rather than a list. So let's save it. And now, if we select some more companies, our company value updates to the latest selection of the user. Now, in terms of dates, what happens if we choose a different start date? Okay, beautiful. Our graph updates accordingly. Now, the only thing that bugs me here is that we can only see the company symbol right beside our ID. So what if we display the company name as well? Well, back in our GUI, we will scroll a bit down so my head doesn't block the rest of the code. And right beside our curly bracket, we will add a separator character followed by another set of curly brackets. And inside them, we will include a very long line of code that starts with company data in the column of short name, where the company data column of symbol is equal to company in the index of -1. Okay? That was a long one. And since this will return a data frame, we will also need to convert it into a NumPy array with dot values. So let's save it. Let's make sure it worked. And okay, we are almost there, but instead of returning a list, let's return the only value in the list by focusing on index 0. Let's save it again, and now our ID is perfect. And now the only problem is, which is pretty much the elephant in the room, is how come we are not displaying our graph once the app loads? Why do we need to select a second company in order to display our graphs? It doesn't make any sense, so let's fix it. Now, one way we can do so is with another built-in function named on_init. And unlike onChange, it is only called once when our application loads. But just like onChange, it also receives a state, a name, and a value. Now, what we want to do inside this function is submit all our scenario inputs and retrieve all our scenario outputs. So let's go ahead and copy the entire content of our company and dates condition, and we'll of course fix the indentation. But our scenarios also have another input and another output. So we will copy our state scenario country write command, and we will paste it at the very top. And we will do the same for our state company names read command, which we will paste at the very bottom. So altogether, we have 3 inputs, which we update here. We then submit the scenario and run both our functions, retrieving our graph data and our company names at the very end. So let's save everything. Let's navigate to our browser. And now if we refresh our page, our graph displays immediately. Amazing! We can finally move on with the machine learning stuff. Now, in our case, we have a sequential dataset that collects daily information all the way from year 2010. Now, each of these days is what we call a sample, while each of these samples has 6 numeric values, also known as features. So for example, the highs, the lows, and the volume are all meaningful features. Now, in addition to samples and features, we also have something called targets. So if our features represent the state of the stock today, then the target represents the state of the stock tomorrow. Now, since our app is only plotting the adjusted closing value, then the adjusted closing value should also be our target. But here's the fun part. Our target is not the value from today, but instead it's the value from tomorrow. So for example, for sample number 1, the target is the adjusted closing value of sample number 2. And for sample number 2, the target is the adjusted closing value of sample number 3, and so on, all the way until the end of the data frame. So before we even talk about the algorithms, let's quickly arrange our data in terms of samples, features, and targets. So let's define a new function named split_data. Now, this function will receive our stock data as well as a set of dates and a single company symbol. Now, since we already know how to filter our data based on some dates, let's quickly copy our temp data variable from the build graph data function and let's paste it in our new one. It will, of course, fix the indentation. And instead of focusing on our adjusted closing feature, let's go ahead and return all of them like so. Then, since we are no longer receiving a list of symbols, but rather a single company symbol, we can actually bring back our symbol filter from earlier, selecting only the rows where the stock data symbol is a perfect match to our function input of symbol. Ha! Now let's go ahead and print our temp data, and initially let's call this function on a global level just so we can see very quickly what's going on, and let's pass it a symbol of Lulu. Let's save it, let's have a look in the terminal. And great, we have the same starting point as in my demo. Now, the only problem is we don't really need the symbol column because our symbol never changes. And we also don't need the dates column because our data is already arranged in a very nice sequence. So then back in our code, let's get rid of these columns by calling the drop method on our data frame and passing it a list with the date column as well as the symbol column. Additionally, we will specify the axis of 1. Let's save it. Let's have another look. And beautiful, we are now only dealing with numbers, which is also the only language that machine learning models understand. So let's start by extracting our features, which in our case is each of our rows one at a time. Now back in our code, we will go ahead and say features equals temp data dot values. But how about our targets? Well, we already determined that targets equals temp data in the column of adjusted closing, but shifted one value forward, which we can do by calling the shift method on our series and passing it the value of -1. And then lastly, we will convert it into a NumPy array with dot values. But wait a second. If we are shifting our data one value forward, it also means that we are losing our very first value in the process. So how exactly will this features and targets thing look like? Well, let's go ahead and quickly, temporarily assign temp data in the column of targets to our new variable of targets. And then let's match our features to their respective targets. And okay, we see that the very first target is a perfect match to the adjusted closing of our second set of features. And we can also see that our second target is a perfect match to our adjusted closing in our third set of features, which means that the issue is probably at the end of the data frame, where it looks like we are missing a target for our very last set of features. But it kind of makes sense because that's the value that we are actually trying to predict. We don't have this information yet, but we want to calculate it with the help of our models. So we will use our last known set of features as a special evaluation sample. So back in our code, let's do the following. Let's focus on all the features up until the one at index -1. And we will do the same for our targets, basically slicing off the last row. But instead of getting rid of it, let's store it right before our features and targets as eval_features. And we'll of course assign it to tempData.values in the index of -1. So before we get rid of this information, we will actually save it. Now let's go ahead and return our features as well as our targets right beside our eval features. And this completes our lovely split data function, and hopefully my head doesn't block most of it. Great, so now that we've arranged our data, we can finally move on with the algorithms. Now, our first algorithm is called linear regression because it uses the linear equation formula to calculate our predictions. Our next algorithm is called k-nearest neighbors. It finds a k number of similar samples, let's say 3 or 5 of them, and then based on their values, we determine a prediction for our values. Now, the last algorithm is a recurrent neural network, and it is very similar to the model from my previous Taipy tutorial. So if you're curious, please check it out. It is beyond the scope of this video. But before we implement our predictions, let's take care of the backend infrastructure. Now, in our case, we already have placeholders for each of our predictions. So let's go ahead and turn these 3 into actual data nodes. And we will, of course, configure them, starting from the data node with the ID of lin_pred and the variable name of lin_pred_cfg. And we will, of course, repeat the same for the ID of knpred and the variable name of knpred_cfg. And lastly, apply the same on our RNN prediction. And as you may guess, these would be the output nodes to tasks that don't exist yet. Now, since we want to calculate these predictions in parallel rather than just one by one, we will go ahead and assign them to different tasks. So let's copy our task from below and let's revise it to get_lin_cfg. We will then make sure it receives our dates and company configurations as input, and it returns our lin_pred_cfg as output. In addition, let's assign it to a not yet existing function named get_lin with a matching ID. Now let's copy it and let's apply it on get knn_cfg with the output of knn_pred_cfg, the function of get knn, as well as a matching ID. And same goes for our last but not least algorithm. That's a lot of copying and pasting. Now let's go ahead and configure our tasks inside our scenario configurations. So into our task_configs, we will pass get lin_cfg, get knn_cfg, and then lastly get rnn. Okay, so now we just need to implement the functions associated with these tasks. We will do it right above. We will define get_lin, which takes in a set of dates and a list of company symbols. It also returns our lin_pred global variable. Now, the first thing we will do inside our predict functions is, of course, call split data. And then our split data function will take in our static stock data, as well as our dynamic dates and the most recent company selected by the user or company in the index of -1. We will then unpack it into features or X, into targets or Y, as well as evaluation features or eval_X. Now, to make sure that nothing breaks, we will go ahead and assign lin_pred to a value like 8, and we will also print that get lin was called. And that should be a good starting point, so let's copy this get lin function, and let's replace every instance of lin with knn, and same goes with our get rnn function, replacing every instance of knn with rnn instead. We're almost done. Now we need to update our scenario, but where? Well, how about everywhere we update our dates and company data nodes? So let's scroll to our onChange function, and then everywhere we have dates and company write commands, we will also need to include the respective read commands. So let's copy the state graph data one, and let's apply it on our predictions. So first we will say state linpred, which we will assign to state scenario linpred read, and same goes for the rest of our models. But that's not the only place where we update our inputs. We also update them inside our onInit function. So let's just copy our 3 predictions, and let's also read them on init. Whew! Now to make sure it worked, let's save everything, let's refresh our browser, and yay! We get a bunch of 8s instead of a bunch of 0s, which means that something worked. And if we look inside our terminal, we can also find the output of our print statements right over here. Amazing! Our backend is fully functional, and we can finally move on with the algorithms themselves. Now, in terms of setup, we will pip install a framework named TensorFlow, and we will pip install a library named Scikit-learn. Then, in terms of imports, we will simply copy them from the description to save some time, where we basically need the linear and the k-neighbors regressors from Scikit-learn, as well as the models and layers from TensorFlow Keras. Then, we will need to create our models before we can use them. And the idea is we create our models once, and then we reuse them every time we make a prediction. So at the very bottom of our code, right inside our ifName equals main block, we will go ahead and create our lin_model, assigning it to the class of LinearRegression from Scikit-learn. And we will of course wrap it in an empty set of round brackets. Then similarly, we will create our KNN model, assigning it to the k-neighbors regressor, also followed by an empty set of round brackets. Now, in terms of the RNN model, it's a bit more complicated. So let's just copy our build RNN function from the description, and we will paste it right above our ifName equals main block. And there you go. Totally easy peasy. Again, if you'd like to find out more, check out my previous Taipy tutorial. Then, inside ifName equals main, we will create RNN_model, assigning it to my build RNN function and passing it the number of features that each of our samples has. In our case, we have 6 of them. And great, we've now created our models, and we can finally use them every time we make a prediction. So let's start with the lin prediction. Now, in the first stage, we will pass our features and targets into the model so that it learns the data really well in a process called training, which we will implement with lin_model.fit, passing it our features first, or x, followed by our targets, or y. Then, once our model is done training, it will then use all the information it learned to make a prediction, which we will do with lin_model.predict, to which we will pass our evaluation features only, or eval x. And then once we have a prediction, we can then assign it to our linpred output. And since the predict method returns a NumPy array instead of a single value, let's return linpred in the index of 0 rather than linpred itself. So let's save our file, let's rerun our app, but instead of getting our prediction, we get a value error. And the reason is the shape of our training features doesn't match the shape of our evaluation features. So if we try to print the shape of our features first, and then we will print the shape of our eval features, we see that our training features have 1 dimension more than our evaluation features. So to fix it, we will do something called unsqueezing. Now back in our split data function, right after we assign eval features, we will reassign it to eval features.reshape, passing it the shape of 1 minus 1. And now, if we take another look, we finally have the proper number of dimensions. Instead of storing an array, we basically store an array of arrays. Great, so what does it mean about our value? Ha! Beautiful, we actually receive it in the interface. But it has a bit more digits that I would like to see. So back in our code, inside our getLin return statement, we will wrap our lin prediction in a round function, restricting it to 3 decimal points only. And if we're already here, let's get rid of our print statements. And beautiful, our prediction is now much shorter. Now let's apply the same principles on our KNN prediction. And for this, we will just copy our 3 lines of code from before and let's paste it inside getKNN. Then every instance of lin model, we will replace with KNN model. And every instance of lin pred, we will replace with KNN pred. Then if we save it, we return to our browser, we now have a KNN prediction as well. Now, in terms of the RNN prediction, surprise, surprise, it works with the same principles. So let's paste our 3 lines of code and we will replace every instance of lin model with RNN model. And same goes for lin pred, which we'll replace with RNN pred. But since our RNN model is slightly more complex, let's add some more arguments inside our fit method, where the first argument is called batch size. And we will set it to 32, which means that our model will process 32 samples at a time. Not all the samples all at once, not sample by sample, but in batches of 32. Then we will specify the epochs argument and we will set it to 10, which means that our model will go over the entire data from start to finish 10 times one after the other. And then lastly, we will set the verbose argument to 0 because we don't really care about the progress of our training, we only want to receive the results. Now, fun fact about setting a batch size, it usually adds 1 dimension to our data, specifically to our RNN prediction. So instead of focusing on the index of 0, we will focus once again on the index of 0, resulting in a double index of 0 after our RNN pred. Okay, now let's save it. I hope it makes sense. Let's have a look in the browser. And oh wow, what kind of number is that and why is it negative? Well, the reason we get it is because we can't just feed a raw set of features into a neural network. We need to normalize them first or reduce the range of their values. So for example, instead of dealing with values between 0 and 500, it is much easier to deal with values between 0 and 1, or in our case, something similar. So back in our code, we will find our split data function, there you go, and then right before returning our features, we will call features.mean over axis 0. Then we will assign this expression to mean, and right below it, we will call features.std, as in standard deviation, also over axis 0. We will then assign it to std. And once we calculated our mean and standard deviation, we will then subtract the mean from our features with features minus equals mean, and we will divide our features by the standard deviation with features divided equals std. And now, since we've done it for our training features, we should also do it for our evaluation features. So let's just copy our subtraction and division commands, and instead of features, let's apply them on eval features at the very bottom. Let's save it. Let's have a look in the browser. And okay, now we are dealing with a proper prediction and no negative numbers. But the only problem is we have way too decimal points to my liking. So let's go ahead and adjust it inside getRNN. And okay, we are rounding, but it doesn't work. So what if we wrap our prediction in a float function, converting it into a floating point number before rounding it? Okay, hopefully it will solve it. That's the fastest solution. Let's check it. And perfect! Our app looks amazing. Now let's go ahead and test it for the very last time. So let's select a different country and a different company, somewhere in the middle, somewhere random. And okay, let's have a look at the predictions, and we see that the RNN network is way more optimistic than the rest of the models. Now, what if we choose another company? Our KNN is now a bit more optimistic than RNN. So what if we change the dates? Let's focus on anything from year 2022. And oh wow, everything adjusts immediately. And what if we get rid of one of these companies? Everything still works as expected. And what happens if we trim the end date? What if we go for the 1st of October? Then our prediction changes a bit as well. So amazing. Folks, we now know exactly how to make a beautiful application with Taipy. We've built a GUI, we've learned some data science, and we've figured out how to get 3 amazing predictions for tomorrow. Now, I highly encourage you to continue working on this app on your end. And if you come up with something really cool, please upload it to your GitHub and please share the link to your repository here in the comments or anywhere on social media. Now, if you enjoy Taipy, you can actually help them develop it. So navigate to their GitHub repository right over here and see how you can contribute. And thank you so much for watching. If you found this video helpful, please share it with the world. And don't forget to leave it a huge thumbs up and all kinds of comments. Now, if you'd like to see more videos of this kind, you can always subscribe to my channel and turn on the notification bell. I'll see you soon in another awesome tutorial. In the meanwhile, bye-bye!